section 3.2, example 7. While I'm here, I organized example 6 a little better. Hopefully you can see that work easier if you needed to take another look at that. Okay, here we go. Suppose theta is between negative pi and 0. Let's think about what that means. So let's draw a graph. Negative pi would be over here. 0 is here. So theta is some sort of angle in here. So it has to be either quadrant 3 or 4. And cosine is negative, so that would be quadrant 3, right? So that means if we take an angle from quadrant 3, so that would be between 270 and 180. 180 to 270. And we split that in half, so that would be 90 to 135, right? So that's a quadrant 2 angle. So theta divided by 2 is a quadrant 2 angle. The reason that's important is that quadrant 2 sine is positive, but in quadrant 3 sine would have been negative. So we have to understand that distinction between the fact that theta is quadrant 3, but the theta divided by 2 is quadrant 2, so sine is positive in quadrant 2, even though it's negative in quadrant 3. Okay, let's go ahead and use our formula to do the problem. Change colors here. Okay, so we have the sine of theta over 2. The formula for that is square root. I'm not going to write plus or minus because I already figured out that it's plus. 1 minus cosine theta over 2. Alright, let's simplify this. So we're going to start by plugging in the cosine that they gave us. So 1 minus negative 3/5. Yes, we have a double negative in there, and that's going to be important. I want to just get this little explanation stuff that I made. Just get that out of the way a little bit. Thank you for your patience. Should pause perhaps. Okay, so that gives us 1 plus 3/5, because when we subtract a negative number, we add a positive number. Alright, I'm just going to start working with these fractions. Common denominator, simplifying. So there's our common denominator. We add those together. We get 8/5 divided by 2, which is actually 8/10. Now each of these steps I've been lazy and haven't put in that square root that's there. Let's do that again. Equals 8/10. So if we simplify our radicals, we'll have the square root of 8 over the square root of 10. We want to rationalize, which we don't always have to, but I think it's good to review it. So that would give us the square root of 80 divided by 10, because square root of 10 times square root of 10 is 10. And the square root of 80, let's see. 80 is divisible by 16, which is a perfect square. 16 and 5. So the square root of 16 is 4. And then 4/10 reduces to 2/5. So our final answer, rationalized, reduced, would be 2 square root 5 over 5. We could just leave it unrationalized, but we would still want to reduce it, in which case I could have done that in this step. 8/10 reduces to 4/5, and that would have saved me bigger number reducing later.